And here we are. Hello, everyone. Good morning, good evening. Welcome to the September Apache Geode community meeting. We like to do these every month or so to explore technical topics within the Apache Geode community, what's going on in the code base, interact with the developers and the community. And today we have Patrick Johnson, who was going to be sharing what he's been working on with regard to class loader isolation and how this is going to make it super easy to build your Spring apps with Apache Geode. If you would like to contribute to one of these, we are doing these on a monthly basis, or you can schedule one anytime that you're ready to talk about something. So talk about it on the dev list. We'll get you scheduled and ready to go. Anyway, without further ado, Patrick, I'm going to turn the mic over to you. Feel free to start sharing your screen and tell us what you're going to talk about.
Okay, let me get that set up. Let's see, share this. There we go. You guys see my slide?
You are good to go.
Okay, great. So, hi everybody, I'm Patrick. I'm going to be talking about some of the work that Udo and I have been doing related to class loader isolation. So let's jump into that. So to start, what are we actually trying to solve? What problem do we have here? So essentially the problem is, if you deploy a jar into Geode, server-side jar deployment, and that jar uses some library, and Geode uses the same library, but the versions don't match up, you have the potential for conflicts and bad things can happen there. So this was originally brought to our attention by users trying to deploy a newer version of Spring than the version Geode was currently on at the time. But this absolutely applies to anything. It's not just Spring. That just happens to be the thing that people are wanting to use on the server that Geode also uses. But like I said, it could be any library. So what are we going to do about this? What's the solution? So when we deploy a jar, rather than just deploying it straight into the system like we currently do, we're going to deploy the jars into isolated modules so that they don't get to mix with the base system like before, and no one's going to get confused about classes. And before I go any further, we need to answer this basic but very important question of what is a module? Because module is a word that I'm going to use a lot throughout this presentation. So a module is something that has its own class loader, and that's how we're going to achieve this isolation, is that things in the jars module are going to be loaded in one class loader, which is different from the rest of the system. So there's different than how we're used to things with Java, where everything's on the system class loader, but we're going to have things separated that way. In addition to having its own class loader, the jar is also going to define what resources it's going to load itself. Classes, jars, other things. Rather than just having everything be on the class path, it's going to specifically define what it brings in. It's also going to define how it depends on other modules that it gets to talk to. And it also gets to define what things are exposed from it and what things are imported into it from other modules. So it gets to control its own boundaries that way. Okay, so now that we know what a module is, how are we going to do this? How are we going to go about modularizing this? So we're going to use a library called JBoss modules, which is something that Udo and Jake actually found out about, decided to use quite a while ago with some of the like pre-work and pre-design work they'd done on this whole modular concept. And this is going to allow us to start the system in a modular way that we can get this kind of isolation that we're looking for. So what's going to happen here is, rather than everything being on the class path, where currently we have the whole of Geode loaded up in one place, there's going to be almost nothing on the class path. We're going to have just JBoss modules and some of the code that we've written to hook into JBoss modules. So much shorter than it currently is. And then all of the stuff that was previously on the class path, all of the different Gradle subprojects of Geode, so Geode Core, Geode GFish, etc., all of those are going to become their own class loader isolated modules within the system. And then when we deploy jars, those are going to become their own modules that we're going to start up at runtime. So let's talk a little bit more about JBoss modules. So as I just said on the last slide, this is the library that we're going to use to be bootstrapping the system in our modular way. This is what's going to give us that modularity. So JBoss modules is used by the Wildfly application server, which you may have heard of. So this is a project that's been around a while. It's been well tested by the world, which is good because we want something that's going to stick around and something that's going to be stable to base all of this on. And this is a very important feature that JBoss modules allows us to load and unload or create and uncreate modules at runtime, which is very important for when we are deploying jars, because that's exactly what we're doing. We're going to be creating new modules on the fly as users deploy new custom code to the servers. So the way that this is configured for startup is JBoss modules is configured using these module XML files. So we'll have a directory structure containing several of these, one XML file for each module. And that's just going to contain the information the module needs to know to start itself up. So it's going to have its name. It's going to define the resources that are loaded inside of it. It's going to contain information about what other modules it has to depend on. And that's also where it's going to define like the filters of what it can import, what it can export, things like that. What things are exposed. Now, we don't want to have to maintain all of these XML files because every time anyone changes anything of what modules need to depend on each other, we'd have to go rewrite them. So we've created a Gradle plugin that's going to generate these XML files for us off of the Gradle information, because Gradle already knows what libraries we're using, and it knows what subprojects need to depend on each other. It's got all that info. So we're just going to have it generate that for us into a form that JBoss can consume. So the point at which JBoss then becomes part of the system is when we start the process. So when we go and launch a server process, rather than launching, currently we would launch the main method out of the server launcher class, like when you're launching a server from gfish, that is. So rather than doing that, we're actually going to launch the main method out of JBoss and then point it at what module to start. In this case, the Geode core module, because that's where server launcher lives. And then that module is going to have information about what main class it should run. So it will know once it's started up, it needs to go run server launcher. So it's just kind of a little indirection there. But this is important, that the way that we start this system is when we start the process. From the word go, this whole thing's modular. And this here is an example of a module XML file that we would have to configure this. So this is specifically the definition for the Geode core module. If you see up here at the top, we've got the name and the associated version here. This can support versioning, so you can either declare something with a version and it'll look for that specific one, or you can declare it without a version and there's a mechanism that it can go and try to find the version, or find some version of this thing to use. And then down here, we've got this resources and resource root section here, where it's just declaring the stuff that's going to be loaded by the module. So here, this is the Geode core jar, and this path is relative to where this module descriptor, this XML file, is defined, and it's just going to go find the jar file that's in Geode's libs in its install directory. And then this is the main class that I talked about on the previous slide, where it points at server launcher so that it knows when the module is started up, it needs to go run that. And then this section down here at the bottom, this is where we have dependencies on other modules. The one I've highlighted is Geode logging, but as you can see, there's several other modules that core depends on here. So while I'm talking about all this module stuff, you might have another module framework coming to mind, Java modules that we introduced in Java 9. So is that what we're doing? No, those aren't the same thing. They do have some similarities because JBoss modules was largely the inspiration for Java 9 modules. It came first, and Java just took some of the concepts from it when making their own modular system. So if you were to look at the configuration for Java modules, it's got kind of a similar structure. It's just not in XML, but it's got a similar structure. But the two are also different in the fact that Java 9 plus modules is a compile time construct. So it's going to prevent things like splitting packages across modules and enforce what things can and can't be accessed or exposed from modules. But you're not actually going to get any runtime isolation. We're not going to have different class loaders for all of these modules, which is something we definitely need. JBoss, on the other hand, doesn't do anything at compile time because it's not part of the language. It's just a library that we pull in and deal with later. But it does actually give us separate class loaders for things. So these two things, while different, do definitely complement each other, because Java 9 can potentially catch some things, prevent some bad things from happening that could pose problematic later when JBoss is actually enforcing the separation between modules at runtime. But we don't need to be on Java 9 or above to do what we're doing. Okay, so let's talk a little bit about how this whole system is going to be structured now that I've kind of described what we're doing. So this very simple diagram here is essentially what Geode looks like now. It's one bucket that has everything in it. That's it. And when we deploy jars, those are just going to essentially get deployed into that bucket. So what we're proposing is something more like this, which I should start by saying this Geode core system blob that we have here. This is not one module. This is a stand-in for a whole bunch of modules that represent the actual system. So Geode core, Geode logging, Geode everything else, all the libraries, that's in Geode core. And then we've got this application thing hung off of it. And what that is, that's essentially a link between the system and the deployments and all the deployments and each other. And one cool thing that we've got through this application is we actually enforce what things can be exported back to the core system. So we basically make sure that nothing that comes in from it, so nothing that comes in from any of the deployments attached to it, if it's in the same, if anything there is in the same package, or in any packages that exist in Geode, whether it's the org Apache Geode package or the package for any library that it uses, it's not going to let that come back into the core system. So the system can't be polluted by any of the stuff that's being deployed in. No one's going to be able to go and deploy like a fake version of something and potentially mess with things. So just from a security perspective, we keep those things separate. But then with the deployments, while they are still isolated themselves, they'll be a little more visible if you wanted to, say, deploy something that, you have some classes in one deployment and then some function that uses them in some other deployment. That's fine because they can connect through that application. That application is kind of a logical grouping of deployments into one application. Right now, we only support a single application, so there's really only the one logical grouping. But that's something that we might potentially expand later. So this is a view of what that core system actually looks like. As you can see, it's kind of a mess, arrows going all over the place. If you look kind of in the upper center, upper right, you'll see Geode core gets a lot of things connected to it. It's kind of the center of the world. This is all just generated off of the information that Gradle gave us that we have here. So nothing super duper important here. Just know that all of these modules are up and running and talking to each other. And one thing you might have noticed in that former diagram is that there were a few modules missing. I mean, we had Geode core, but we didn't have Geode gfish. We didn't have Geode, the Redis APIs and Memcache and Lucene or anything like that. So why is that? Those modules, this whole list here, are what we're calling extensions. And this isn't something that we created. This isn't something that we put into Geode. This already really existed. There's an interface called cache service that's implemented in several different subprojects, and that is the Redis service, the Lucene service, and things like that. And all of those get service loaded at startup and initialized and set to be running. But really, they aren't actually necessary. They don't have to be there. They just get loaded up. But if the classes weren't present, it wouldn't really cause a problem. Other things don't depend on them the same way as the other modules do. They're extensions, they're add-ons. So what we have the ability to do now here, because everything is class loader isolated, is if we didn't want to, we wouldn't have to load them. You could only load what you want. We could dramatically cut down the amount of stuff that is started in Geode, which is kind of cool. Okay, so I've pretty well described, I think, what we're doing. So let's talk about where we are with that. Currently, we've done about 90% of it. We're feature complete, pretty much feature complete. We've got the work in place that we can hook into the JBoss world to be able to deploy new modules. We've got the Gradle plugin written that can generate our module XMLs. We've done a bunch of refactoring around the jar deployer in Geode and around class path loader and stuff like that so that we can get things properly deployed and make sure classes can be loaded the way that we expect, functions can be registered, all that stuff. We've eliminated some places where packages were being split across modules, which becomes a problem that I'll talk about a little more later. And now, right now, you can just go into Gfish, start up a server, specify the flag that we've set to turn all of this on because it's opt-in. And you can go deploy a jar with some different version of some dependency, Spring, for instance, and it'll work. We won't have that conflict anymore. So we've got that. So what do we have left? We have the other 90% of stuff left. We're at the point where we're just testing this. We've already written some tests ourselves that show that this works, but we're trying to get this integrated with some of our bigger test suites like DUnit, so that we can get some of that, that huge amount of test coverage, so we can have some real confidence in this before we go and try to release it. So we're just working through failures with that. Most of the issues we've run into haven't been like fundamental flaws in our system so much as just inconsistencies with how the tests work. The fact that now, instead of having the Geode core module be the center of the universe when starting a server, the Geode DUnit one now has to be the center of things, and stuff have different test dependencies and need to get a hold of the test classes themselves for places that, modify the class path or go and execute some lambda of code on the server somewhere. Little things like that are just posing to be issues, but we're working through that. So I'm going to talk about a couple of the things that we're now able to do because of this, a couple things that we've enabled. So the first is the obvious. We've fixed that initial problem, is you can now deploy dependencies of whatever version, and you're not going to run into conflicts with what's currently in Geode. But also what we've enabled is related to that extension stuff. Not only can we choose not to load them at the beginning, we can actually load and unload them at runtime. So really, this has become like a plugin framework here that you can drop and load or potentially even upgrade individual components one at a time without having to stop the server. So you could, you started up and you decide you wanted Lucene, but you didn't want Redis. Later on, you decide you want Redis. Okay, you can turn that on. And if you don't need Lucene anymore, you can turn that off. And potentially, we could even upgrade things, get some new version of Redis, and deploy that into the system and have that running without even having to shut things down. You can update individual components because everything really is separate and isolated from everything else now, which is pretty cool. So I'm going to do a little demonstration now. So what I'm going to do, I'm going to start a couple of servers in Gfish. I'm going to start one using our experimental flag and one without, and I'm going to show that that we're not going to have conflicts with Spring, and then I'm going to show you some other cool stuff. So to start, I'm just going to start a locator. Nothing super exciting here because we didn't do anything different about locators. This work only applies to the server because that is where the deployed jars live.
Bueno.
So we'll just wait for this to start. There we go. Then we're going to start a server. I'm just going to name this one. I'm going to name this one modular. And we're going to set the experimental flag, which eventually needs to be renamed, but this is just what tells Gfish to go and launch the server in this modular way. So now we're going to start another server. I'm just going to name it normal, and then set the server port so it doesn't complain at me. Okay, and now I'm going to go and deploy. Let me see. So I'm going to deploy a Spring function. So this is a pretty simple function. All it's really going to do is it's going to go look up a couple of bean definitions, which are just strings, and slam them together and print out a message for us. But what's interesting about this function is that Geode is currently on Spring 5. And this function is actually using Spring 4, and that's all bundled into this as a fat jar. So there should be conflicts, except, well, now there shouldn't. And we'll see how that works. So you do list functions. There it is, Spring function on both servers. We're going to execute the function, Spring function. Need to capitalize things. Spring function. And as you can see, on our modular server, the status is okay, and it just gave us our message back. And on the other one, it had an error. Now, why exactly this is a null pointer exception? It's a good question, but essentially this all just comes from it's somehow messing up what classes it's getting, and bad things are happening because Spring is not working as it's expecting. So there you have it. We've solved the problem. So what I'm going to show you now, and this the gfish commands I'm about to show you, I just whipped up for this presentation. They're just demo to show you some of the infrastructure that we've put underneath. We just needed something to exercise those. These aren't something that we're necessarily going to release with the first revolution of this, and certainly not something we're going to release without a little more work. But I'm going to deploy another function. I've just called it a function. And what it's going to do, it's going to go and look for all of the cache service implementations that it can find in the system. Make this go away. It's going to look for all the cache services and just print out the ones that it can find. So we've got that deployed. So we'll go and execute, called it extfun for extension function, because it's going to go find all of the extensions. So as you can see, our modular server doesn't have very many things. But our other server has a whole bunch of services. So the reason for this is because just for this demo, I decided to disable several of the extensions. So disable Redis and Lucene and Memcached and a bunch of things like that, just to show that we don't need them. The server can start up without them, and now we can add them at runtime. So I can do enable extension, and let's go add Geode Lucene. So right here, it's returned true that it succeeded on the modular one. It failed on our other server because, well, we don't have any concept of adding or removing modules there. So its default implementation is just to return false. But now let's go run this function again. And look, we now have the Lucene service. And we can go do the same thing, but maybe I'll add Memcached this time. Look, we have even more stuff. And then if we wanted to, we can disable those extensions too. So disable Geode Lucene, and then we'll go and run this. And what do you know? Geode Lucene isn't there anymore. So yeah, back to the presentation. Okay, so that's what we've done. We've solved that problem. Here's some things that we've learned in the process of doing all of this work, and things that we'd like you guys to be aware of as members of the Geode community and a lot of you as developers. So first of all, package splitting across modules isn't a good thing anymore. So if you were to have, if you were trying to access like a package protected member in another class in the same package as you, normally that would be fine. But in the modular world, that doesn't work because those two classes are going to be loaded in different class loaders. And even though you're technically in the same package, it's not going to recognize it that way, and you're going to end up with an illegal access exception. And this is something that we ran into while we were doing this, that we had to do some refactoring to fix that. And this isn't just something for our work or just something for JBoss. Java 9 modules will disallow this from the beginning, that it won't even let you build if you're splitting packages across modules like that. We've also learned that it's important to be mindful of module boundaries. And what we mean by that is like where classes go from one module to another. When some piece of API that is exposed from one module to another involves maybe some library class or some class within that library or within that module, you just have to think about that, because if we end up in some situation where some libraries, maybe some jars loaded twice, some classes loaded twice in different modules, that's fine, but as soon as they try to talk to each other, as soon as that class crosses the module boundary, you're going to end up with problems, because class A defined in module 1 is not the same class as class A defined in module 2, and it'll tell you, hey, you know, this isn't the same class. I don't know what to do with this, whether you're trying to assign it or compare it or anything like that. And this one is really important. So Gradle dependencies obviously have always been important, but now they're more important because before, if you wanted access to something, you didn't have to declare that you needed it runtime, or you could say you only needed a compile time or something. And then you could just kind of assume that it exists on the server, or that it exists on the class path. If you try to load something later on, it'll just be there. You'll have access to it because everything's in one bucket. But now you don't get any of that for free because the modules just won't connect to it. I mean, it's not everything is on the class path. We don't have one big bucket. Everything's separated. So if you need access to something, you actually have to explicitly depend on it, which in most places we do that. But there were a few places we ran into where things were expecting access from something in some other module that it didn't explicitly say it depended on. So if Gradle doesn't know about it, our plugin can't know about it. So the module descriptors don't represent that, and we don't end up with that connected to the modules at all. So those are just some things to keep in mind going forward once this work eventually makes it into develop. I'm also going to talk about just a couple of things that we'd like to do in the future that probably won't make it into this first release, this first revision, but that we would like to eventually do. We'd eventually like to support multi-application deployments. So instead of just having that one application, we could have multiple. You can have multiple logical groupings of deployments that are all isolated from each other and grouped together. Different applications isolated from each other. We'd also like to have more of a life cycle with extensions. So what I just showed you about loading and unloading those extensions, that's cool, but it's not really finished because all I did was show you that we were able to load and unload classes at runtime. This doesn't do anything to actually go and start the Redis service once it becomes available. So that's something else we'd have to add, is some kind of life cycle for that. Because currently those interface, the implementations of cache service are just loaded up kind of when the system starts. So if they're not there at that point, it's not going to get started. So even if it becomes available later, we don't have anything to say, hey, by the way, go look for all the implementations now and start those. So there needs to be some kind of way to initialize those services after we make their classes available. We'd also like to do a little more work on the Gradle plugin that we might be able to make it useful to users. Right now, it's only something we use internally, but we would really like if this is something that users could use to run against their application, generate their own module descriptors, that they could then add those into the system and be able to better control like what their module structure looks like instead of just getting kind of the default, oh, you've given us one jar, we're just going to make this a module. There it is. They can modularize their own system and give us that. So these are things that we'd like to work on in the future, but aren't going to get to on this first MVP. And that's it. That concludes my presentation. So if anyone has any questions, now would be the time.
Thanks, Patrick. That was super cool stuff. I'm seeing a few questions in the chat. I will go ahead and forward to you. So one was about the memory impact on running a server without extensions. Have you seen any difference there?
So we haven't done any like profiling to see exactly what the memory consumption is, but I can tell you it starts up faster if we don't load all those extra things. So we don't know though beyond that.
Okay, cool. One other question I saw was a question: if I'm a user and I have my classes for my application split across two different jar files, like a domain jar and maybe a functions jar file or something, and I deploy both of those jars, can classes in jar A reference classes in jar B?
Yes, so that's kind of the point of the application that we were talking about, is things within the application are still isolated, but if it's trying to use some class that doesn't exist inside itself, it can still go out to the other deployments and find it from there. But if we were to have multiple applications, things wouldn't be able to see each other across applications.
Gotcha. And if I made the mistake of putting all my classes in the same package but different jar files, would would I have an issue there?
Potentially, if you were trying to take advantage of any of the like package private stuff, you'd end up with issues there. But I don't think there's some inherent problem that it will just explode for no reason. It just won't recognize those things as necessarily being like in the same package for the sake of accessing protected members.
Thank you. Other questions? Perhaps someone wants to jump in and ask directly.
I actually added another question. I just wanted to be clear that you can have multiple modules that depend on another module, right? You declare that in the XML file.
Yes. Yeah, you can have a module can depend on any number of things, and any number of things can depend on any given module.
Okay. No.
Just out of curiosity, have you tried to see what happens if you're, like, say you're using the WAN module and then you unload it? Like, I'm just, not that it's not a sensible thing to do, I'm just kind of curious, like, what happens?
We have not. So as I said, like this whole loading and unloading that I just demoed, this was something that I just kind of pulled up for this presentation. We put all of this groundwork in there so that we could have some like kind of better plugin system in the future. But we haven't really done a whole lot of testing with the idea of actually like dropping and loading stuff like that at runtime. Because that's kind of that's something I think we're kind of hoping to get in like a second iteration through being able to do something like that. We just want to leave the groundwork for that now. But that is something we should play with, because I would be interested to know too.
Yeah, Donald. The scenario in that situation is that it will unload the module, but as soon as you have, it's like garbage collection. If you have reference, so you hold on to a reference to the class, it will hold on to that reference to the class until you let go of it. And as soon as you let go of it, there's no chance for you to get it back. So if you had WAN set up and you had all WAN classes instantiated and somebody's holding on to them, and then you drop the WAN module, it will behave as like anything else right now. It would just hold on to it, and as soon as we lose reference to the class instance, that's at that point we actually lose. So we lose the ability to actually access or actually interact with that class itself. But as Patrick said, I think if we were to, I think what he's showing you is really, it's just sort of what we can do. But as he's pointed out, we want to go get a lot stricter framework around that. What does it mean if we unload something? How does it? There needs to be a shutdown process, a whole big life cycle around that, so that we don't accidentally start deleting things or shutting things down that we don't want to do.
Hey,
Another
I came
question.
a little bit late, but I was curious, what's the difference between a JBoss module if it's supporting the loading and unloading and OSGI?
I'll admit I don't know a whole lot about OSGI, so I can't answer that very well. But I've heard everyone tell me that OSGI is terribly complicated. So maybe that's the difference.
Yeah, if you've never done any Eclipse programming, yeah. But I know that was one of the big heated discussions around Java modules when that was coming out with J9, and it does support loading and unloading. So I was just kind of curious where JBoss went with that. If they used OSGI as their foundation, or if they went somewhere else.
So what we're doing is not OSGI. Like I said, I don't know a whole lot about OSGI other than it's not what we're doing. But yeah, I wish I could answer that better.
Mm-hmm.
Other questions from the audience for Patrick? One question or comment was, it would be cool to see if any of the additional class loader injection causes any performance differences. Do you have any insight on that at all yet?
We don't really have any performance benchmarks around any of this. Any more questions?
I'll surface a comment I made earlier in the chat. I thought it was great that you're also thinking about some tooling to help see what's going on inside the guts of the server with class loaders. If you've ever had to deal with class loader debugging, it can be quite frustration inducing. So the more we can help our users see what applications and modules are deployed and how they relate, I think it will be a benefit to them when something isn't working the way they expect, which is correct, but maybe not exactly what they had wanted.
Yeah, definitely. We want to make this easy for users and other developers to figure out if something were to ever go wrong.
Cool. Well, I could jump in with another question. I know you've got that other 90% to do, but as you think about a user who has existing applications and wants to start using this, and maybe they don't have just like one application, they've got hundreds of applications. What do you see as the migration path to adding this feature to their applications?
I mean, once it's released, just upgrade to the newest version, and they'll have to restart their servers with that flag. And then beyond that, they should be able to just, there it is, deploy everything that they had before. I don't imagine there should be any huge changes otherwise, except now they can go use different versions of things if they so chose.
I think my view is that there should be no difference at all from the user's perspective, other than having to restart the server with the flag turned on. Because I mean, if they happen to deploy code to the server already and it was working, then it won't break in the new way. The only thing it will do is it it will now give us a class loader isolation capability. I don't know if you've noticed, but when Patrick was demoing, he started a server using class loader isolation and another server that wasn't class loader isolated, and they actually work perfectly fine together in a cluster. So a rolling upgrade scenario is actually not unheard of in the situation, that a customer could actually very easily just do a rolling upgrade and they get to the latest class loader isolated manner, and that's fine.
In this model, I noticed you had a hierarchy view of like a user's modules and the application, and then Geode. If I'm bundling my jar, should I include all of the libraries it depends on as well, even if they're already on the Geode class path?
So if you just wanted to use whatever Geode has on the class path, and you're not too picky about what version of Spring or what version of something else you're getting, then that's totally fine. You don't have to bundle any of that stuff, because you would still be able to get those things out of the Geode system. But if you didn't want to use those, if you wanted to use some other version, then you'd have the option that you could build that into your jar, and your application would find those first before it goes out wandering through the Geode system looking for classes.
Yeah, and as like say a best practice for our users, what would we recommend? That they deploy like a fat jar containing all of the dependencies in one, individual jar files, for every dependency. Maybe this goes beyond, a Geode question and what people in the Spring world, think is the best.
I would say that probably having a fat jar would be best, because then you can just be most sure of exactly what you're getting. That you have full control over all the dependencies that you're bundling in there. But I imagine that, people could do various different combinations of things depending on exactly what they wanted. But I would say a fat jar is probably the safest.
And I think we know that Spring has some great tooling to help you sort out what those dependencies should be across, a very complicated Java ecosystem. So probably don't have time to get into what that looks like here, but there's a lot of good resources out there for building Spring Boot and Spring Data applications using Apache Geode.
Definitely.
In fact, I think we should do a shout out here to John Bloom, who's the author of some of that stuff. So thanks for joining us today, John.
Yeah, sure thing. Happy to be here. Good presentation, Patrick. Really liked it.
Thank you.
Right, should we do a last call? Any further questions for Patrick or any other community topics we wanted to cover today? All right, folks. Thanks so much for joining. Great job to Patrick. And if you want to be on stage next month, please give a shout out on the dev list and we'll get that set up. So expect the next session to happen in early October, and we'll see you online then. This recording will be posted to the wiki page where we keep track of all these things. And we'll see you next time. Thank you and have a great day.
Thanks, everybody.
Bye.